throughout our video lessons on random variable, we looked at this example where this round circle here represents the spinning wheel, similar to that spinning wheel in the Wheel of Fortune. And as a brief reminder, so this, once we spin the wheel here, if the needle lands on this particular sector, then we are going to win $1,000. And of course, these are equal sectors. We only had 8 sectors in this wheel right here. And if the needle lands at the end of the spin, if the needle lands into either one of the 2 labels here, 2 or 3, then we have a winning value of the game being $100. And further, if the needle here lands on any of these 3 labels, 4, 5, or 6, then we can win $10. And then there's one particular label where one particular sector here labeled win nothing. So meaning if the needle lands there, we're not gonna, at least we're not losing, but we are earning $0. And here in that game, as a reminder, then if the needle lands into that area here where it says a bankruptcy, then we're gonna lose a flat amount being 1,200. So this is a losing amount being taken out of your pocket if the needle lands in there. And in that example, we realized, and I spent some time explaining how we define and how we had the, so let me first redefine the random variable x here. So x to represent the outcome as money amount. Of each game. And so in that video, I already explained how this variable here can be regarded as a random variable. And so we constructed a probability, we constructed the probability distribution for this game here as if x is being the value for coming out of each of the game, each time we spin the wheel here, then x can be value $1,000. But there's a probability that if x equals $1,000, then the chance there is only, the probability there is only 1/8. I'm coming straight out from the way how this simple wheels work. We got one nice wheel with 8 perfectly equals sectors. So the chance of winning here is just only 1 out of 8. And we also set up that $100 as the winning value. We can have an x can take value equals 100, but the chance that happens is only 2/8. It's a little higher than the other chance. And then x can, on the other hand, equals to $10, where the probability is 3/8. And there's also a chance that our needle can land right into that win nothing, where as an outcome value, we have a $0. And the chance it happens is a 1/8 chance. And the last one on our list here, we can lose 1,200. So putting as a real value, real money value, this is the value coming out of your pocket, so it's a negative amount, 1,200. And the chance that happens, the chance that our random variable equals to that is a 1/8 chance. And so I spent some time already before in our lecture explaining how this game can help us see the concept of random variable here. And of course, this table that we constructed in our example before was also referred as the probability distribution. Of our random variable x. So anytime, as a reminder again, in the concept of random variable, anytime we are working with a random variable, then we have to have a probability distribution of some kind that comes along. The probability distribution lists values that our variable can take, and also lists the chances, the probabilities, that how much chance, how much probability the variable can take on each different distinctive values here. But now looking further into this particular example, this example is a perfect example for demonstrating the idea of a, so this random variable here is now we are heading into understanding that as a discrete random variable. And so once again, let me repeat, but throughout our lecture before on random variable, we simply just understood this as a random variable, out of the amount of this game here simply as a random variable. But now furthermore, we understanding this. I'm about to explain why this is a perfect example for being a discrete random variable. And so, what is a discrete random variable, and why is that random variable in the example we just briefly looked back in our previous lecture considered as a discrete random variable? As an English term, discrete means something that is individually, it's an adjective, and it means individually separate, or individually, or being distinct. And really that concept being discrete lives in our truthful understanding of discrete random variable. And so what it means in our random variable, that being a discrete random variable, is that random variable must have a limited number of values. And I'm using the term limited here to make it more a little more friendly, but really limited here, just something that means countable. And so it's just the way some random variables are. For example, right back at our example that I just brought up right before we start into the discrete random variable, on that Wheel of Fortune game right here, the reason we refer to that random variable as a discrete random variable, because just the way how the game was set up, we can only have these limited number of outcome amount. So our random variable previously defined could be equals to 1,000, or equals to 100, or equals to $10, or equals to 0, or equals to negative 1,200. And these are the chances correspondingly: 1/8 chance, 2/8 chance, 3/8 chance, 1/8 chance, and 1/8 chance. But I have to emphasize, those are all they are for the values. And what I mean is, according to the way how this game was set up, that Wheel of Fortune game was set up, we can only find values among these being listed here. You won't, in other words, if you're looking for a probability of when you can win a $150, this chance is simply, well, as far as being listed on the table, it's not listed in our probability distribution here, so the chance here is automatically 0. And that's what it's meant by having a limited number of values. We have only in this table over here we have only 5 different values here in this game, and no matter, and don't get me wrong on this, but I'm talking about having a limited number of values, and these values are being distinct, but we still can have an infinite number of runs, and each time we can add into any values that bounce back and forth between any of these limited values here. So we can still have an unlimited number of values of data. So that's why it's still a population data, but we only have no matter how big our population data is, we only have the values being bouncing back and forth between these values only. And that's crucially important for the understanding of discrete random variable. We have a limited number of values. As another example of discrete random variable, let's look at that situation where we're rolling 2 independent dice. So we're starting out by rolling 2 regular 6-sided die. Regular 6-sided dice. So allow me to create a chart like this. If we, and I did use that term independence, truly meaning the 2 dice here, the outcome on one die has nothing to do to affect the outcome of the other dice. So die 1, when you roll 2 dice, then die 1 can give independently any of these outcomes right here. 1, 2, 3, 4, 5, 6. And the same with die 2. When you roll both of them, die 2 can also independently give you the outcomes as following: 1, 2, 3, 4, 5, and 6. And so now if we are looking at the sums of the outcomes onto 2 dice together, so if die 1 give a 1 and die 2 also give a 1 by chance, then we have a sum being 2. And notice that is the smallest sum. And then so on, if die 1 gives the outcome on a 2, but die 2 still gives the outcome on a 1, then we have a sum being 3. And then here we can see that there's a repetitive pattern how we can create all the sums of the outcomes from the 2 dice. So 2, 3, 4, 5, 6, 7. And so this table now completes listing out all the sums of rolling 2 regular dice. And so, and think about it, we can let's look at the sum being 8 right here. So 8 is the value, but really we have 1, 2, 3, 4, and 5 different sums, indicating that this 8 right here can be the sum coming out 2 on die 2 and 6 on die 1. This other 8 here can be a sum, value being 8, but it comes out being a different sum because it came out from 6 on die 2, but 2 on die 1. And so now, generally speaking, we have different values here of the sum. So I'm going to define a variable. X is to represent, I'm going to let X represent the sum of the two numbers after rolling. Two dice. Then in the way how we define our variable, that way. Then one more time, looking back at the complete list of all possible sums here, then we can really have actually 36 different sums here. And so as far as making a complete list of the values of our sum, then the lowest value of sum can only is a 2. Then we can have a 3. That sum can be 4. That sum can be 5. The sum can be 6. the sum can be 7, the sum can be 8, then the sum can be 9, and the sum can be 10 or 11, and the last sum, I'm running out of space here, so allow me to continue my table in the next space to the right hand side here. But the last value of the sum here, we can go as high as being 12. And so now, I mentioned that there are 36 possible sums here, so being 2, the chance, the probability that our random variable representing the sum of two numbers after rolling 2 dice, that chance there when x equals 2 is only 1 out of 36. And the chance of being 3, so if we quickly count through, there are 2 3s here in the entire 36. And so it's 3, and I mean 2 out of 36. And there are, for the 4s right here, there are 3 out of 36, and so on, and we don't really need to reduce the fractions. And then 5, there are 4 out of 36. And so now, these are all the probabilities listed for the corresponding values of our x representing the sum of the two numbers after rolling the dice. And so, once again, in our study of the random variable, we can quickly double check that these probabilities entries added up to 1. And so this is clearly a probability distribution But then, really, my intention is not to study again what random variable means, but now what I'm seeing here is it's just the way of how we define our random variable. Then naturally, it's going to become a discrete. What we have here is another example for having a discrete random variable. And the only reason being, once again, the way how the variable was defined, that it can only have these limited number of values. If we're looking at finding the chance that our sum of the two dice rolling to a 3.5, for example, that chance is completely off this table, completely off this probability distribution. So that chance is a 0 chance. And so, once again, this example demonstrates that idea of having a limited, we have a limited number of values. And once again, we can roll as many times as we want, and so we can run into an infinite number of sums. But anytime we run into a sum, we only have the value of the sums bouncing back and forth among these values only, and these values are being limited. And that's what the intention of a discrete random variable is. And now anyone viewing the video lesson at this point must have noticed that I first started out by giving the definition of the word discrete as meaning individually separate or distinct. But then I spent so much time explaining how a discrete random variable has a limited number of values. Then so in that way of my explanation that has been finished, why do we call a random variable in that way a discrete random variable? why do we call such random variable discrete? To make it consistent with the formal English term definition. And so now if we are one more time looking back at the two examples we have investigated throughout this discussion here. On the left hand side here I've had written down the probability distribution of the example where the random variable x represented the outcome as money amount of each game. So this was the example, the probability distribution for the Wheel of Fortune example. And this on the right hand side right here is the probability distribution where x represents the sum of the two numbers after rolling two dice. And so this was the example where we roll two dice and x represents the sum of the two dice right there. And so I have spent so much time explaining that the way how these two random variables are, once defined, then they naturally have a limited number of values. As you can see here, this random variable has only 5 different distinct values. And now I just start saying that word. Because they have a limited number of values, so naturally the way it is, they can only have these values will appear to be distinct. And so the same with these values being listed here on my right hand side probability distribution. The way how this random variable is defined, it has a limited number of values. So consequently, each value here, each value among all the values of the random variable is distinct from the other. And another way of seeing is that once we purposely put any of these probability distribution in a certain order, from here it's from low to high, top down, or here it's from high to low, top down, then once we put these values in order, that we can notice that we can find out that there's a between any two adjacent values. Say for example in here 3 and 4, they are adjacent value. 110 in this example here, these two are adjacent values. And so in any of these examples, there's a permanent gap, a space, a gap, or an interval that exists permanently between these two values. And that's what it means by being separate, being distinct. So there's a gap here between these two values. There's also another gap here between these two values. And so having gap between the values, any two adjacent values, is a feature that's making this kind of random variable being regarded as the discrete random variable. So here 8 and 9, they are discrete from each other because they have a gap between. And now realizing that adjacent values in any of our random variable throughout the examples, they are having gaps, permanent gaps between them. That's why these random variables are being referred to as discrete random variable, because they are distinct. Each value is distinct from the other ones, and each value is individually separate from the other ones. And that's how it's making it consistent with the definition that's given as an English term. And as a last note for any viewers out there who view my video lessons on the introduction of random variable, then all approaches that you found in those videos were more heavily based on the discrete random variable. It's just easier that way to start introducing any random variable as a discrete random variable. And once everybody has a nice, clear understanding of what random variable is, and now I'm introducing what exactly in detail a discrete random variable is, and then after we've learned about being a discrete random variable, then the plan now is that we're going to be moving on. We're going to be moving on to a different class of random variable that's referred to as continuous random variable.